Wow! For plate vibration, depending on wave number, some wave evanescently decay. So use your cell phone. Therefore, radiation is G direction, evanescently decay. How to do it? How to do it? Think about it. And in this region, radiate very well, and we call this radiation circle. Radiation circle. This region exponentially decay, and in this region, radiation. Okay. Okay. In addition, along this center line, the vibration look like this. Number of mode in X direction and number of mode in Y direction is equally likely. Okay? As getting go away, we will get this kind of vibration. And what would happen? The radiation pattern would be this one and this one cancel out, and so on, so on. So therefore, the radiation look like coming from the edges, only edges. Remember, the radiation due to this is canceling out all the way, right? So if I have more mode, the interior part will cancel out. The only remaining part would be some sound radiation from this corner. Okay, so this we call corner mode. Along this line, the plate vibration would look like what? Like this vibration. And we can say that this one cancel out, only edgy mode effectively radiate the sound. Okay? So what would be one way to suppress the sound radiation from vibrating sphere? Make a lot of mode. Let them vibrate in many, many modes so that they can fight each other. And if you know that the plate vibration has many modes, where is the location or area you have to put your sound observing material? If it is edgy mode, only need to put the sound observing material over here, not over here, because they are fighting each other. They all cancel out by themselves. Right? If you just to understand the vibration, you may control all the vibration along this plate, but as you understand using this acoustics course, you know the radiation pattern based on that, like this. You may design wisely the way to reduce the sound. Let me summarize. We learned a lot today. We learned a lot today. We start with breathing sphere, trembling sphere, and vibrating piston. And we reviewed the sound radiation. And I emphasize the measure that really determine the radiation is Ka and Kr, and we look at those things in terms of radiation impedance, driving point impedance, and the directivity index. And the directivity index certainly provide us the radiation characteristics in space. And using principle of superposition, I argue that any plate vibration can be constructed as the superposition of a vibrating piston. Okay? And then I introduced the concept of wave number in z direction. That certainly has a very interesting potential or to explain the sound radiation by the plate. It's all conceptual because you can predict the sound using Kirchhoff-Helmholtz integral equation. You can make a simple MATLAB code that can handle it. That would be interesting homework problem again for the next week. Right? But for preparing Thursday quiz, try to focus on basic concept. Okay?